Hello everyone. So now let's look at the second problem of this contest, which says small x stable index 2. So we are given an integer array nums of length n and an integer j. For each index I, define its instability score as the maximum till that index, that is maximum of nums of 0 to I minus minimum of I to n minus 1, right? In other words, right, max of is the largest value from index 0 to I, and min is the smallest value among all the elements from I to n minus 1. An index is called stable if its instability score is less than equal to k, right? Whatever this value gives you, let's call it val. So if your value is less than equal to k, that is your index, right? So you need to return the smallest stable index, right? Let's look at the test case to understand the problem statement more clearly, right? Uh, so I have already uploaded the problem C. If you haven't seen, you can check it out, right? So what does this problem say? Not uploaded, it's getting edited. Don't think that before contest gets over, I'm submitting. No, that's not the case, right? Okay, so let's look at the test case, right? So what I'm trying to say is, let's say for this index, what is the maximum till this point? Max is 5, min is beyond this, which is 3, right? So difference is 2, right? Is this difference less than equal to k? Yes, it is. No, it is not. Minimum is 0, right? So the value which difference we get is 5, right? Is this difference less than equal to 2? No. Move to the next one, right? So at this point, what is the maximum? Maximum is still 5, minimum is 0, right? So what can you do is, you can simply say, okay, the minimum after this point, from this point to end is 0, that is 5 minus 0 again, which is again 5. It is useless. Now let's come to this point. What is the maximum till this point, which is 5? What is the minimum from behind to this point? It is 4. It is 1. So 5 minus 1, 4, right? It is still failing, right? Okay. Now let's go to 4. What is this maximum till this point? 5. What is the minimum till this point? 4, right? Because minimum from here to here is 4 only, right? So it gives a value 1, which is less than equal to 2, right? 3 rather, k is 3. So yes, it is true. And now you can return this index. This was the first index where we got the value, which was 3, right? So I hope the problem makes sense to you. Now, how about the approach? I think the problem is not that very tough if you try to think. If you had a nums, right, and if you created a vector maxi, which will store the maximum till that point, till that I index, right, and you create a minimum. What does this minimum do? Minimum will traverse from end, right? You will traverse from end, and what you will do, you will store the minimum value till this point, right? So minimum will start from end and store its value, right? So whenever you are standing at any position, you do definitely know that, okay, at this point the minimum which I have got is this. Let's create this minimum for this vector, which was 5014, right? We will create everything, right? So first create maximum. How will this maxi look? Maxi will look like 5, 5, 5 and 5. And how will this mini look? Mini will start from end, right? 4, 1, 0, 0, right? Now you have these two values, right? Now think of this. When you are standing at this index, you know to till my left what is the maximum, right, which is 5. When you are standing at this position, you know till this index what is the maximum, that is 5. If you are standing at this position, you know till my left what is the maximum, 5. If you are standing at this position, you know 5. Now let's look at the mini. What does this mini say? If you are standing at this index, what is the minimum to my right till from this point to the end? It is 0. If you are standing at this position, what is the minimum to your right including this index? It is 0. If you are standing at this position including this index, what is the minimum that you have? It is 1. If you are standing at this position, what is the minimum you have? You have 4. So this is the useful thing we can do in vector, right? Now, as we got this, now we can simply traverse on this loop, right? And find the difference, right? Difference while traversing on this loop. What is 5 minus 0? It is 5. What is this? 5. What is this? 4. 5 minus 4 is 1. I hope you understood how we did it. Maxi minus mini, maxi minus mini, maxi minus mini, and maxi minus mini. And as soon as we get a value which is less than equal to k, we return that, right? Because that will be the first index. Is this less than equal to k? No, no, no. Yes, it is, and we return that. So I hope the logic is clear to you, right? Let's look last test case and we will simply jump into the code, right? This doesn't have a value. Let's look at if what happens if you don't have a value. 3 to 1 and value is 1, right? So 3 to 1 and value of k is 1, right? Create the maxi. How will the maxi look? Let's quickly think of it. It is 3 till this point, 3 till this point, 3. And what is the mini? How will the mini look? It is 1, 1, and 1, right? Now let's create the difference. 3 minus 2, 1, 2, 3 minus 1, 2, 2. Is the value at any point less than equal to k? No. Every point is 2 and k was 1. So we failed. So we will return a minus 1, right? I hope the logic for this is clear to you. Let's jump into the code, right? So what I did, we created maxi and mini, right? Maxi of 0 is nums of 0. Whatever the first value is, that will be the first maxi, right? We will traverse from 1 to n, and maxi of I is maxi of I minus 1 comma nums of n. I hope this makes sense to you, right? So for example, 3 to 1, right? How will our maxi look like? Maxi initially we marked as 3. When we went to this position, what will be the value of maxi of I? It will be either maxi of I minus 1, which is this, or the current value, which is 2. What is maximum? 3. So put 3. When it came to this index, what will be the value? Either maxi of I minus 1, which is 3, or the value I, which is 1. What will be the maximum? 3. Put it. Move on, right? Mini of n minus 1 is nums of n minus 1. Initially, the minimum value on the right side is that value itself. And we will traverse from n minus 2. We'll go till 0 and do the same thing as we did in the maxi part, right? Same index, but here we are doing minimum, right? And then what we can do, we can traverse from 0 to n. We can find the value which is maxi minus maxi of I minus mini of I, right? If this value is less than k, you return that index I, right? Else you continue the for loop. At end, if you can't return anything, we will return a minus 1. So I hope the problem statement was clear to you. Let's look at the time complexity of it. We run a big O of n loop, right? Nothing more than that. We use a simple for loops, right? And what is the space complexity? Space complexity is big O of 2n, right? Which is ultimately big O of n. One more thing, you can optimize this using means if you are using maxi vector, right? You can cut down that maxi vector into maxi, right? Maxi is nothing but the maximum value we got till now, right? Because see, while you are traversing on this array, right, you can simply store the maximum value. You don't need a new vector for it, right? So in that way, you can reduce the space complexity to big O of n instead of big O of 2n, right? Anyways, this will still get accepted as I showed you, right? And I hope the logic was clear to you. If it was helpful to you, please do like, share, and subscribe. Thanks for watching. If you have any doubts on this or any other problems, you can definitely ask in the comments. I will help you out. Thanks for watching.